Section 1. Introduction. IP tables is the built-in firewall for Linux, providing a flexible framework for controlling network traffic. You can define rules to allow or block connections based on various criteria. By mastering IP tables, you gain granular control over your system's security posture. IP tables is essential for Linux systems because it acts as a barrier between your system and the outside world, enabling you to filter incoming and outgoing network traffic. This protects your system from unauthorized access and malicious activities. With IP tables, you can define specific rules to govern how your system interacts with other networks. IP tables operates on a set of rules. These rules determine how the firewall handles network packets. Each rule specifies conditions for matching packets and actions to take if a match occurs. You can customize these rules to meet your specific security requirements. Understanding the fundamentals of IP tables is crucial for any Linux administrator. It's the foundation for building a robust and secure network environment. By learning how to configure and manage IP tables, you can effectively safeguard your system from a wide range of threats. Section 2. The significance of IP tables. IP tables is more than just a firewall, it's a powerful tool for shaping network traffic. You can use it to perform network address translation, or NAT, which allows multiple devices on a private network to share a single public IP address. This is essential for connecting to the internet. IP tables also provides quality of service, or QoS capabilities. You can prioritize certain types of traffic over others. This ensures that critical applications receive the necessary bandwidth. For example, you can prioritize voice over IP or VoIP traffic to maintain call quality. The flexibility of IP tables makes it suitable for various use cases. You can use it to set up a simple firewall for a home network or configure complex rules for enterprise-level security. Its versatility makes it an indispensable tool for network administrators. Mastering IP tables is an investment in your system's security. It empowers you to control network access, prevent intrusions, and optimize network performance. Whether you're a seasoned administrator or a Linux enthusiast, understanding IP tables is essential for maintaining a secure and efficient network environment. Section 3. Understanding tables. Filter, NAT, and mangle. IP tables organizes its rules into three main tables: filter, NAT, and mangle. Each table serves a distinct purpose in managing network traffic. The filter table is the default table and handles packet filtering. The NAT table is responsible for network address translation. It modifies the source or destination IP addresses and ports of network packets. NAT enables private networks to connect to public networks using a single public IP address. This is crucial for internet connectivity. The mangle table allows you to modify the IP headers of packets. You can use it to set quality of service, or QoS, bits, or change the time to live, or TTL value. This table is less commonly used than filter and NAT, but it offers advanced control over packet handling. Each table contains a set of chains, which are lists of rules that are applied sequentially to network packets. Understanding the roles of these tables is fundamental to configuring IP tables effectively. It allows you to organize your rules logically and achieve the desired network behavior. Section 4. Navigating chains input, output, and forward. Within each IP tables table, there are predefined chains that represent different stages of packet processing. The three main chains are input, output, and forward. These chains determine the path that packets take through the firewall. The input chain handles packets destined for the local system. Rules in this chain control which incoming connections are allowed or blocked. For example, you can block connections from specific IP addresses or ports. The output chain processes packets originating from the local system. Rules in this chain control which outgoing connections are allowed. You can use this chain to prevent your system from connecting to certain destinations. The forward chain deals with packets that are routed through the system. This chain is relevant for systems acting as routers. Rules in this chain determine how the system handles traffic passing through it. Understanding the function of each chain is crucial for creating effective firewall rules. You need to apply rules to the appropriate chain based on the direction of the traffic you want to control. Section 5. Targets, defining actions for packet handling. In IP tables, targets specify the action to take when a packet matches a rule. Targets determine how the firewall handles the packet. Common targets include accept, drop, and reject. The accept target allows the packet to pass through the firewall. This is the default action if no matching rule is found. You can use this target to explicitly allow specific connections. The drop target silently discards the packet without any notification to the sender. This is a common target for blocking unwanted traffic. The sender will not receive any response, making it appear as if the connection timed out. The reject target sends an error message to the sender, indicating that the connection was refused. This target is useful for providing feedback to the sender, informing them that the connection was blocked. Choosing the appropriate target depends on your security requirements. Accept allows traffic, drop silently blocks it, and reject provides feedback to the sender. Understanding the nuances of these targets is essential for crafting effective firewall rules. Section 6. Matches filtering network traffic with precision. Matches in IP tables define the criteria for filtering network traffic. They allow you to specify conditions that packets must meet to trigger a rule. You can match packets based on various attributes such as source IP address, destination port, protocol, and more. Common matches include S for source IP address, D for destination IP address, P for protocol, Sport for source port, and D port for destination port. These matches provide granular control over which packets are affected by your rules. You can combine multiple matches in a single rule to create complex filtering conditions. For example, you can allow SSH connections only from a specific IP address range. This level of precision enables you to tailor your firewall rules to your specific security needs. Mastering matches is fundamental to creating effective IP tables rules. By understanding the available matches and how to use them, you can precisely control which traffic is allowed or blocked by your firewall. Section 7. Rule syntax, constructing effective firewall rules. IP tables rules follow a specific syntax that defines the match criteria, target, and other options. Understanding this syntax is crucial for creating and managing your firewall rules. A basic IP tables rule consists of the following components: IP tables, T table, a chain rule specification, J target. T specifies the table like filter, NAT, or mangle. A appends the rule to the end of the specified chain. Rule specification defines the match criteria, and J specifies the target. For example, to block all incoming traffic on port 80, you would use the following rule: IP tables, T filter, A input, PTTP, D port 80, J drop. This rule specifies the filter table, appends the rule to the input chain, matches TCP traffic on destination port 80, and sets the target to drop. You can customize IP tables rules to suit your specific requirements. By understanding the rule syntax and available options, you can create a firewall that effectively protects your system from unauthorized access and malicious activities. Section 8. Allowing SSH connections, a practical example. Let's illustrate the use of IP tables with a practical example. Allowing SSH connections. SSH is a secure protocol used for remote access to Linux systems. To allow SSH connections only from a specific IP address, you would use the following rule: IP tables T filter, A input, PTCP S192.168.1.100, D port 22, J accept. This rule specifies the filter table, appends the rule to the input chain, matches TCP traffic from source IP address 192.168.1.100 on destination port 22, SSH, and sets the target to accept. This rule ensures that only connections from the specified IP address are allowed to access the SSH service on your system. All other SSH connections will be blocked by the default drop policy of the input chain. This example demonstrates how to use IP tables to create specific rules for controlling access to your system. By understanding the rule syntax and available options, you can configure your firewall to meet your specific security needs. Section 9. Best practices. Maintaining a secure firewall. Effectively using IP tables involves more than just creating rules. It's essential to follow best practices to ensure your firewall remains secure and efficient. Regularly review your firewall rules to ensure they are still relevant and effective. Remove any outdated or unnecessary rules to prevent conflicts and improve performance. Keep your IP tables configuration organized and well documented for easy management and troubleshooting. Implement a default drop policy for all chains. This means that any traffic that doesn't explicitly match a rule will be blocked. This provides a baseline level of security by preventing any unintended access. Use logging to monitor firewall activity and identify potential security threats. Logging allows you to track blocked connections, rule matches, and other relevant events. This information can help you refine your firewall rules and detect suspicious activity. By adhering to best practices, you can maximize the effectiveness of your IP tables firewall and maintain a secure network environment. Section 10. Conclusion. IP tables is an indispensable tool for Linux system security. It provides a flexible framework for controlling network traffic and protecting against unauthorized access. By understanding the core components of IP tables, chains, targets, matches, and rule syntax, you can create a robust and secure firewall tailored to your specific needs. Mastering IP tables empowers you to control network access, prevent intrusions, and optimize network performance. Whether you're a seasoned administrator or a Linux enthusiast, investing time in learning IP tables is essential for maintaining a secure and efficient network environment. By implementing best practices and staying informed about potential threats, you can leverage IP tables to safeguard your system and ensure its integrity.